Okay, let's take a look at today's lesson. Today's lesson is on right triangle trig, or right triangle applications. And this really should be a review for most of us, so I just chose just a random problem to work, just to kind of get your minds back into right triangle trig and how that works. Then we will work through our daily work. So let's take a look at this particular example. We have scientists that estimate the heights of features on the moon by measuring the lengths of the shadow they cast on the moon's surface. From a photograph, you find that the shadow cast on the inside of a crater by its rim is 325 meters long. So let's pause there for just a second and draw. So we have a rim, we have its shadow, 325 meters long. Now let's kind of reconcile that we know that the rims aren't going to be vertical, but if you could imagine a vertical line going through to the bottom, you know, the edge of the rim, that would kind of help you with this picture. This is the, I guess, just the vertical line going down to the bottom of the crater. Alright, so here's our shadow. So we have, at the time that the photograph was taken, the sun's angle of elevation from this place on the moon's surface was 23 degrees 37 minutes. Alright, so let's talk about angle of elevation. Now, for whatever reason, for many students, angle of elevation is confusing. We need to keep in mind that the angle of elevation is never, ever made with the vertical line. Always with the horizontal. Okay, and actually, if you look, whether I'm looking at this angle or this angle, whether I'm looking at the angle of elevation, you know, or the angle of depression, they're the same angle. Think back to geometry. Two parallel lines cut by a transversal, alternate interior angles are equal. So regardless of which one we're talking about, whether we're talking about this one, which would be my angle of depression, or this one, which is my angle of elevation, they're the same angle. Okay, so you probably know that already. I'm just making a big point of it because that usually is a confusion. We don't ever make it with the vertical. It kind of seems like, oh, well, that looks like the angle of depression right here. I mean, I can see why that would, you know, kind of be logically, oh, well, that's it. But it's not. It's the one with the horizontal always. So it would be more convenient to use this one, so that's what we're going to use. That one is 23 degrees 37 minutes. Now, since we're working with triangles, it's going to be important that our calculators are in degree mode. I know I like radians better, and I wish triangles, you know, that was a common thing for it to be in radians, but geometry teachers would not be very happy with me if I decided, oh, let's just change the triangles to radians. I don't really think that would go over very well. So we're just going to have to live in degrees, you know, for right now, for the triangle applications and those kinds of things. When we're talking about polygons, we need to be in degrees. So we need to have our calculator in degrees. And this whole lesson is a calculator lesson, so hopefully you have yours with you. So let's continue. Let's try to see what they're wanting. How high does the rim rise above the inside of the crater? So what we're looking for is this measure. That's what we're looking for. So we have this angle measure, we have adjacent, and we want opposite. So that sounds like a tangent or a cotangent, doesn't it? Now, since tangent is on our calculator, that's really easy, I'm going to go for a tangent, see how that works. So we'll do tangent of 23 degrees 37 seconds, and I'm going to write it like this because that's how I'm going to input it in the calculator. That's how I'm going to input it in the calculator. Tangent of 37 is, so tangent is opposite over adjacent. So basically the value I'm looking for is going to be 325 times tangent of 23 plus 37 over 60. Okay, so I'm going to go ahead and pull my calculator up, and I'll just work through that with you. Are there any questions so far? Are we okay with this? Just a pretty standard problem, isn't it? It's a pretty standard right triangle trig problem. So let's go to the calculator. Okay. So we want tangent. Well, first of all, we need to be sure we're in degrees, right? When we reset our calculator, it defaults to radians because, of course, that's the coolest one. But we need to be sure that we're in degrees, so, you know, make sure that that's changed in your calculator. and then we're going to do tangent. And the way that I like to input the degrees, minutes, seconds is like I showed you. There are other ways to do it. If you look, like there's this blue like little angle thing, you can mess with that. For me, it's just faster to type it in instead of trying to, because I don't use that feature very often. So I'm just going to type it in, you know, 23 plus, then I'm going to do a fraction, alpha, y equals, enter. 23 plus, what is it, 37 over 60. Okay, whoops. Okay, so that gives me, that's going to give me my angle measure. And then I'm going to multiply that by the 325. Okay, so that tells us that the height of that crater, that rim of the crater, is 142.102 meters. Okay, we okay with that? All right, so we would just write, so x is, what was it, 142.102 meters. Now let's talk about the work that you need to show. As I was walking around earlier, I saw some just answers. So just answers aren't going to be okay, right? We need the setup. All I need you to do is give me the problem setup. Like I had here, we had tangent, you know, of 2337 equals x over 325. I mean, that I can, if I just see that and the answer, I'm happy. Right? Can you solve for x? Sure. Yes, absolutely. But I need to at least see your setup and then your answer. Okay? Not just answers. Those aren't okay. So questions on this. It's pretty straightforward, isn't it? There are some more challenging ones that involve multiple angles and things like that. You have some of those on your daily work. But I just wanted to get your mind back into right triangle trig. Okay?